John Rewolinski. I'm a hyperscale data center planning and scheduling expert. I specialize in accelerating and optimizing data center builds for various companies like Microsoft. Currently, I'm working for the program for a company down the road there in Mountain View. Might be a big G on the side of the building. Very, very large data centers at scale. So I built about 1.8 gigawatts of data centers in my career. So, thanks. And I love being a champion of new technology, especially in the construction industry. It's an amazing thing to be able to do, but we adopt technology very slow, and it costs us billions of dollars every year. So I'm happy for CIFE. I'm happy to have this topic today. So pretty quickly, artificial intelligence is a really wide umbrella. There's a lot of different models underneath artificial intelligence. So we've got your LLMs, your deep learning neural networks, and your CSPs, predictive analytics, anomaly detection, all of the things we use today. So I use a program called Alice Technologies to accelerate and optimize our data center builds. And so the issue with construction is that our schedules are very dynamic. Our projects are dynamic. They're always changing. And the traditional tool that we use to plan our data centers is it's really static, and it's just not well equipped for modern projects. So some of the key challenges that we have is they're very rigid. The tools that we use, they're very hard to change when the plan changes, when we run into an issue. It's hard to plan for resource efficiency. Some of the other speakers have alluded to resources are a very difficult part of getting things built. It's hard to find electricians. It's hard to find commissioning agents. It's hard to manage all those cranes. And when you're planning and scheduling these builds, your sequencing is human-driven, right? A lot of times it's suboptimal. And then finally, we have constraint blindness. There's a lot of constraints that we don't factor into planning and building these data centers. So not only do I build AI infrastructure, I use AI to help me accelerate and optimize these builds. Oh, went backwards. So at the company down the road, we're using parametric scheduling to accelerate. Like I said, we're using Alice Technologies. So what this provides us optionality. So we want to have as many options to build these things as possible. We want to be able to see all these options and what the pros and cons of those options are, and allow the business to select the best option based on their needs at the time. We want to have resource efficiency, and we want to have optimum sequencing. If we can do all these things, we can build these data centers as fast as possible, because speed is the name of the game. We're in an arms race between all these different companies to build this AI infrastructure. So getting it done faster is better. So put together a case study. It's a hypothetical case study for legal reasons. And so let's call it a 40 megawatt data center at 500,000 square feet. So typically when we're starting one of these data center builds, we're going to use this parametric scheduling software, Alice, to optimize our baseline schedule. We have schedulers that will create a baseline P6 schedule. It's the initial plan. But a lot of times we run into those issues that we were talking about earlier, the lack of optimization, the constraint blindness, all of those things. So we run it through the software that in very short order optimizes our baseline construction schedule, and we're able to kind of go from there. And kind of the way that works is we import the P6 schedule, which is the CPM scheduling tool that we all use. But then we have to go in and make modifications to that schedule. We have to remove the preferential logic and the crew flow logic, and then we incorporate the resources and equipment, labor resources, and then finally it ends up spitting out an optimized schedule for us based on those constraints and those resources that we provided it. So just quickly on preferential logic for people who don't know about CPM scheduling, we build logic in the schedule that is based on preference. We build crew chase logic, so we have crews that go from activity A to B to C. And so the constraint is not that they, it's not a structural constraint where you have to put in the rebar before you pour the concrete. This is purely based out of availability of resources. And then there's convenience logic, which is just where you're going to start phase A before phase B, before phase C, when really there's no physical relationship between those two things. So when we strip out all of that preferential logic, the parametric scheduling tool, Alice, it optimizes all of those activities into the most efficient path to completion. So with this hypothetical data center builds are running about 9 months right now for most companies. They can go as long as 12 months for a 40 megawatt build. That's down from 27 months just 3 or 4 years ago that these builds were taking us. So we've really accelerated these builds, and so we're always looking for incremental improvements. And so in this example, just with this optimization effort, we were able to accelerate by 15 days just with removing the preferential logic and loading it up with resources and having Alice plan out the path of how those crews are gonna progress through the project. All right, and so another thing that we deal with quite a bit is resource shortages. Electricians are really hard to come by. If you have kids that don't want to go to college, send them to be an electrician because it is going to be the most needed blue-collar trades out there for a very long time. So often what we're dealing with is the number of available electricians and mechanical pipe fitters for liquid-cooled data centers. So in this example, we like to run at about 90 electricians for our smaller builds. So in this example, we were in a region where we only had 60 electricians regionally available in that area. And so what the business wanted to know was, well, if we have traveling crews, what does that look like? If we can only get as many electricians as we have regionally available, what does that do to the schedule? And so we're able to look at, not only are we able to look at a range of options based on that resource availability, but the parametric scheduling tool helped us reorganize those resources more efficiently to complete on time. So if we have, in this example, we had a 25% reduction of available labor force, but the schedule only kicked out by 5 days. And the reason for that is because we were able to use AI to help us resequence and optimize that resource availability. And so finally, the thing that these companies love me for the most is the schedule acceleration part of it. Is again, faster is the name of the game for all data center builds. So in this particular example, I proposed some acceleration options, and so one of the first things I'll generally do when I'm trying to accelerate a data center build is I will run a scenario through the Alice tool, assuming infinite resources. So if I know how it's going to build the schedule with infinite resources, then I know which resources to focus in on, which are the most sensitive to availability, to labor issues, strikes, anything like that. So then the next step I kind of go through is then I propose additional resources to up to the available resource pool. I run some scenarios there, and I kind of gradually work on a grid to fine tune and focus in on what is the most efficient way to accelerate the schedule. And the Alice tool helps me kind of go through this iterative process of optionality and seeing what options are going to give us the biggest bang for our buck. And you can see here, some of the acceleration options are much more expensive, but some of them actually end up being cheaper, which is counterintuitive in the construction industry. We always think overtime is going to cost a bunch more money, it's going to be more expensive, but that's not always the case with schedule acceleration. So that's usually what I'm looking for is what's the nice balance between cost and schedule acceleration. So in this target acceleration scenario, again, it's about a 9-month build. I was able to shave off 32 days. That's a month, out of a 9-month schedule, just with with the schedule acceleration exercise through the AI tool. And what's funny is it ended up not being a factor of how many electricians we had, how many mechanical pipe fitters we had. We ended up finding out through this process that it really ended up being the number of commissioning agents. That's really what held up the project and what allowed us to accelerate further. So it was kind of a revelation when we went through that process. So just a little recap of the actionable intelligence that we gain from using AI to accelerate project schedules in the data center world. We started with a 9-month schedule. Right out of the gate, we knocked off half a month. We only lost 5 days from a major resource availability issue, and then we knocked off an entire another month a little bit later on in the project. So that was a good experience. Just real quickly, I wanted to touch on some other areas that I'm using AI as a practitioner. I'm using LLMs just to kind of help me organize my work. I write a lot of delay analysis letters. I'm trying to figure out what happened, how did this project get delayed, who's responsible, things like that. So I use LLMs to help me write those narratives. I use it for organization, information recall, and brainstorming. So there's a lot of different ways that I'm using AI in the industry to help us plan and build this AI infrastructure. So that's it.
Thanks, John. Just a quick question. How long does one of those iterations take you? Is that 1 minute, a week?
Maybe an hour. So it's all about having the knowledge on which levers to pull. But once you know which levers to pull, the process is very quick. It's minutes, hours, and it's a 2-day workshop session can cure a lot of issues.
So once you had this base scenario created, how long did it take you to run all the other scenarios? Rough, just a day?
About a day, yeah.
Okay.
Yeah.
Just to get a little context there. Yeah. Just a little bit faster than schedules I used to make. So.